Okay, so in this section, we're going to talk about increasing and decreasing functions. By definition, we say a function is increasing if, when you go from an x value to a higher x value, the y values also increase, they go up, okay? If you look at a graph, the way you can see that a function is increasing, we always read graphs from left to right. So as you can see, this one from left to right, it's increasing, rising, and so on. Similarly, we say a function is decreasing if when you go from an x value to a higher x value, then the y values will decrease. Okay, they will get smaller. And if you look at a decreasing function from left to right, you can physically see that it's going down, it's decreasing. A constant function is defined as when you go from an x to a higher x value, but the y values will stay the same, constant. That's a constant function. What's important when we talk about increasing and decreasing functions is we want to give the intervals over which a function increases and decreases, and those intervals are always using the x values, never the y values. All right, so let's take a look at this first function here. It says consider the graph to determine the intervals on which the function is increasing, decreasing, or constant. So we can take a look at this function, and you see that this function goes down here, and it will stretch out into x equals negative infinity, right? So to look at increasing and decreasing, we look at the function from left to right. Starting from the left, we see that this function is increasing, then it decreases, then it increases, and then it's constant for a little bit. So we want to write all the intervals over which the function is increasing. The first interval over which it's increasing is this interval. So this stretches from negative infinity all the way to here to x equals negative 3. So it increases from negative infinity to negative 3. And here I want to do a closed circle bracket, okay? It also increases from here to here, all right? And here, so what are the x values? Positive 2 to positive 6. So I say union 2 to 6. But because they're open circles there, I'm just going to leave them open. Okay, so where is the function decreasing? The function we said is decreasing in this range from here to here. That's from x equals negative 3 to x equals 2. Negative 3 to 2. Closed here, we have to leave it open there. When is the function constant? The function is constant in this region. That's from x equals 6 to infinity. So I say 6 to infinity. All right, let's do a couple more examples. Same situation here. Where is the function increasing, decreasing, and so on? Well, if I look at this function from left to right, it's increasing. It's increasing. The only place where you might sort of pause is in the middle here. It looks like there might be a little, situation where it's constant over there for a slight second. But is it? Let's really take a look at it. Let's look at the function. Remember what we said is that if we go from 1x to a higher x value, the y values will be increasing if the function is increasing. So here in this range, if I keep plugging in higher and higher x values, will the y values ever stay the same? No, the y values will keep increasing. So I know that this function is increasing over the entirety of its life. So this function is increasing from negative infinity to positive infinity. All right, so take a look at this function. This is a parabola. First, it's decreasing until here, and then it's increasing. So it's decreasing from negative infinity all the way to 2 is decreasing. Negative infinity to 2. Increasing from 2 to positive infinity. Okay, next one. This function is increasing from negative infinity all the way to 0. Leave that open. It's also increasing here from 3 to positive infinity. We can close that because there is not an open circle there. And then it's constant here. So from 0 to 3. Okay, next. This next function is increasing a little bit until -1, and then it starts to decrease, and then it's increasing again, right? So it's increasing from negative infinity all the way to x equals 1. Also, I'm sorry, -1. Also from 1 to positive infinity. And then it's decreasing from -1 to 1. Right. So here we come to an important point, which is this. When a function changes from increasing to decreasing, like this one here, look at how there is a peak that's created there. We call that a maximum. When a function changes from decreasing to increasing, there is a valley created there. We call that a minimum, right? So let's go over here and talk about maxima and minima. Together, like as an umbrella, maxima and minima are all called extrema. And when we talk about extrema, we talk about relative and absolute extrema. All right, so let's talk about what that means. A maximum, by definition, is a point where the function changes from increasing to decreasing. Now, if a maximum is the absolute highest value that the function attains, it's called the absolute maximum, and all other maxima are called relative maxima. So here, this maximum here is the highest point that the graph will ever reach. It's called an absolute max. This is also a maximum. It's called a relative max. The same thing goes with minimum, right? If a function changes from decreasing to increasing, it creates a minimum. If it is, this is a typo, if the minimum is the lowest value that the graph attains, it is called absolute minimum. All other minima are called relative minimum, okay? So here, this is the absolute lowest point of the graph. It's called an absolute minimum. This is also a minimum here, but it's only a relative minimum. Okay, note that if you're asked where the maximum or the minimum occurs, that's the x value. If you're asked what is the value of the max or min, that's the y coordinate. Okay, so let's talk about local and absolute extrema here. Local is the same as relative, and if we talk about extrema, that could be either min or max. Okay, that's the generic term for min or max, minimum or maximum. All right, so here and here I have minima. Those are both on equal standing, and they are the absolute minimum of the function, right? They are the absolute lowest point of the function, so they're the absolute minimum. Okay, so this is the point +1, -1. This is -1, -1. So I say the absolute minima are -1, -1, +1, -1. Here, there is a maximum, okay? That's not the absolute maximum because the graph goes up higher than that. So it's only a relative maximum, and the coordinates for that are 0, 3. It's best to put x and y coordinates, that way you've given all of the information. All right, let's take a look at this one. Here we only have a minimum here, And because it's the lowest point that the graph reaches, it's an absolute minimum. And this is at x equals -3 and y equals -4. Okay. Next one here. All right, let's do the maxima first. I have a maximum here and a maximum here. All right, the first one is not the highest point, so that's a relative max. This is also a relative max. So I have two relative max. The one to the left is at -1, 2. The one to the right is in the middle, right? So I could just abbreviate, estimate that as 0.5, 0.5. It's good enough for now to just go as, 0.5. If it's between two integers, we can just estimate it or round it off to the 0.5. We can't go any more to any more precision than that. So we can't say 0.6, 0.3, 0.67. 0.5 is the best we could do for now. Okay, next, let's do the minima. Here we have a relative minimum, and this one is also a relative minimum. Neither of these are absolute because it goes further down. So we have a relative minimum at 0, 0, and another relative minimum at x equals, -1.5, or I'm sorry, x equals 1.5, or I'm even okay with 2, comma, -4.5. Okay, so we're gonna estimate that to be 1.5, comma, -4.5. All right, and we're gonna stop here for day 1. Thank you.